we live? Are we live? Yeah. Hey everyone, welcome back to the channel. Today we are going to continue with our learning. So let's get started.
Just say it's just too long for me. And I just want to reduce this to 3 seconds, okay? So what should I do? I want to change the green and red to 3 seconds. I like the yellow one. It's 1 second. It feels nice. But the red and yellow just feel too long for me. Okay? So what do? I go right here and change 5,000 to 3,000. Not only that too, I have to go back to red, then go change it to 3,000 again. Okay. Then I have to upload it. It's gonna work for 3 seconds now. But okay, let's just check it out. Working. Okay, there we go. It's working. Okay, it's a bit faster now. Let me just count again. 1, 2, 3, then change over. Okay, there we go. It's working pretty fine. All right, but I have to go change it at 2 separate places. So I have to go right here and change this to 3,000. Again, 3 seconds. So I have to go right here again and change this to 3,000. Just think of me having lots and lots and lots of LEDs right here. Let's say I have 5 or 6. I'm gonna have to go change it, what, 6 places. I don't want that to happen. So how do I avoid this type of mistake? So we're gonna learn something called variables. All right, so first, before learning about variables, let's talk about this box right here. So I have a box right here, okay? So this box, no label on it. You do not know what is inside until you open it. When you open it, you know what's inside, okay? So it has no label again. It's just empty. But to save us this effort, and let's say I just checked it and labeled it right here and named it microphone box. Okay, so I just gave it a label. So it's gonna tell me what is inside before even opening the box. So right now, by just reading this, I can say is, okay, this has some mic equipment inside of here, right? Okay, this has mic equipment before even what? Opening it. All right, so this is the nice thing about variables. So what they do is basically refer to things, all right? So they just basically refer to our data. So we can refer to our data without actually changing anything about our data. Our label does not change anything about our box, all right? Doesn't change anything. All it does is what? All it does is reference to our box, what is inside the box. That is what it tells us. So how do we set up variables here? And we're actually going to see even a second purpose of variables. The first one is to reference things. We're gonna check the second use of variables. So let me go right here. Let's see how you set up variables here. So all you need to do is go right here and use the keyword let, if I'm correct. I don't think I use the keyword let here. So all you need to do is write down a name. So let's say I want this to be delay time. So I just write down delay underscore time. Okay. So I'm going to set this to 3,000 and close this. Let me just verify if this is even correct. And it says, no, it's not. Does not name a type. Okay. So right here, all we need to do is go right here and say let delay time. We do that right here. Let does not name a type. So you might be wondering, for those of you who are using JavaScript and all that, we have to tell it what type of data we're putting inside. Right here, we're putting what? We're putting an integer. All right, so we have to let it know the type of data that we're storing. Right? We're gonna say is integer. Basically, it's an integer number. So let me just verify this again. Should be working pretty fine now. Can you guys see it? So we have to tell it the type. So when you're using Arduino, we're gonna have to tell it the type of variable that we're using. So in this case, it's an integer I'm defining here. And obviously I'm gonna give it a name. So I'm gonna call this delay time. Again, this has nothing special on it, so I can just even call it something else that is unrelated to it. I can just say, you know what, it's green, or I can just say phone, or I can just say anything. You get me? but I'm gonna obviously put delay time because that's what is the use of variables, to give us rightful information of what this is. So even before somebody reading my code, they can understand, they can understand before reading this code is that, oh, this is delay time. This is supposed to be the time that is going to delay inside, obviously, this LEDs. Okay, so I'm going to go say delay time and set it to 3000. All right, so let me just set it to 3000. So I'm going to remove this delay time right here. So I'm going to be using it. How do I use it? I just use it as a normal thing. I'm just going to say delay time. I already defined it. I can use it multiple times. All right, also for red, I'm going to go right here and use delay time underscore time. All right, perfect. That's all I need to do. If I verify this right now, I don't get any error. All right, everything's sounding great. If I upload this, as I said again, a variable does not change a thing about what it's referencing. So I earlier said 3000 here, and basically what it's just doing is delay time is equal to 3000 here. So it's basically putting 3000. The computer is manually putting 3000 here, all right, instead of delay time. That's just what basically it does. So the second usage of variables here is that, you know what, this is a bit too fast for me. This thing is just really fast. This is going 3 seconds and then 1 second and then 3 seconds. This is very fast for me. I just want to make it 4 seconds, all right? So I can just do right here is just change it from one spot. I don't have to go multiple spots to change it. I've defined it once. I can do is just change it from one spot and say, you know what, that's what I want. Let me just verify this. Let me upload this. I want it to be 4 seconds. I want it to be in the middle. I don't want it to be too slow. I don't want it to be too fast, all right? So look at this. I upload this right now. It goes 4 seconds. So let me count this 1, 2, 3, 4. All right, there we go. So it goes for 4 seconds, all right? That's all you need to do when it comes to variables. That's why we use them a lot, all right? So,
okay, bro, I'm leaving. Bye.
Bro, how are you leaving so early? You have to finish this website by tomorrow anyhow.
instead of using pin 7 right here, just saying 749, okay, I can change it again to, for somebody who does not know what I'm writing down, before somebody even knows what I'm writing down right here, by just defining these variables, I just save them the time from reading the code. It can also work for yourself when you come back to this code, all right? So I can just say is, you know what, I can call this digital underscore pin equal to, let's see, again, we have 7 right here. So digital pin, let me just say 7 right here. All right, let me just say digital pin 7 underscore 7. There we go. Then I can write this down for 4. Write this down for 9. Write 9 here. Write 4 here. There we go. And obviously replace this digital pins right here. So I'm just repeating 7 right here on pin mode, and also on digital write. I'm repeating it over and over again. Can you guys see the difference right now? So let's say I'm changing a pin. I have to change it at 3 separate places. I don't want that to happen. So all I have to do right now is do the exactly same thing. Write down digital pin 7. It's going to autocomplete it for me. Then go say digital pin 4. And then digital pin what? Digital pin 9. Okay, so I'm just going to replace this again. So one thing you guys need to know is by using Control D or Command D, you can just select the same number over again. So you can select the same thing over again. Say I'm selected 7 right now. I even selected the 7 from the digital pin 7 right here. So you need to be careful. So okay, I'm going to do is select this to 7 right here, and I can edit them at the same time. Okay, edit this at the same time. There we go. When it comes to 4, I only have 2 4s right now left. Do this, and again, set this to digital pin 4. And when it comes to 9, I can again use Control D, select 2, then digital pin 9. There we go. It's not supposed to change anything about our code, but it should make it what? A whole lot nicer and clean, all right? So let me verify this again if it's working properly. Okay, everything seems fine. Let me upload it. And let's check if everything is working properly as it should. All right, nice. Okay, that's good. It's working really, really nice. So you guys learned about variables. So again, as I said, one thing you should know about variables is, as I said again, one thing you should know about variables is what? They do not change anything. All they do is what? Reference. Again, like I talked about the box. The label on the box just basically reference what is inside of the box, but nothing more than that, all right? So that's all when it comes to variables. So all they do is just refer data. They just make it easier and cleaner to store data, all right? All right, with that in mind, let's move to the next section. All right, so let's recap what we've done so far. So at first, we began with the 5 volt right here. We began with the 5 volt and we built a simple LED circuit. Afterwards, we used these digital pins right here. And what we did is again build a traffic light. Okay, so what are these pins marked with an A and a number next to them? We're going to check them out in the next few sections. By the way, these are called analog pins. So in the next few sections, we're actually going to see the difference between analog pins and digital pins. Not only that too, but we're going to see their purpose and why they are important in the Arduino world. So see you then. All right, so let me show you guys what I did right here. All right, so let me show you guys what I did right here. So what I basically did, all right, is that I set up the basic 5 volt LED circuit. So we have a 5 volt right here connected to the red connecting wire, and then we have a resistor and we have our LED, and then we go back to the GND with the black wire. That's all I did. That's what we did when we started this course. Okay, so let me go over to my screen right now and let's start coding. So right here, let me first give this a variable name. So let me say a red pin. All right. Then let me give it a number. Let's say we're using pin 4 right here. Analog pin 4. Let's just say that. Again, I just took it by random. And right here, what we do is, again, as we did for digital pin, what we did was pin mode, right? Then we put our what? Our pin, which pin it is. And then how do you want to use it? You want to use it as an output or as an input? Always put a semicolon at the end of each line. All right, that's what I did right here. But there is a problem right here. So right here, when we're using digital pins, right here, we did was only put the number, right? So let's say I'm using digital pin 4 right here. Let's just say that I'm using digital pin 4. When I'm doing that, what happens? When I'm using digital pin 4, what I did was just put a number right here and set it up like I did for an analog pin. So right here, how do we know the difference between digital and analog pin? So how does Arduino know that we're using digital pin 4 or analog pin 4 right here? Arduino does not know, okay? So every time to differentiate an analog pin from a digital pin, what we do is put a capital A before it, all right? So before the number that we're going to use, we always put a capital A. So it's going to differentiate, and we're going to know actually which pin we're going to be using. So right here, Arduino will not be what? Will not be confused if you want to use the digital pin or the analog pin, okay? So we're going to do is what? Put a capital A.
Need to run Windows on your Mac? Parallels Desktop makes it simple
Beforehand. All right, so once I'm done setting up the pin mode right here, what I need to do is go here, all right? So what did we do right here? We said digital right, and we set it to what? What do? We put the red pin right here, and then we set it to high when we were using a digital pin. So right here, it makes sense to write what? Analog pin. There's something called analog right, okay? We do that, and we see a red pin, okay? The pin that we're gonna be using, and then we're gonna put a value. So right here, I'm just gonna put 255, and I'm gonna come back to this and actually explain why did we put 255. So let me just remove this right here, because obviously we're not using a digital pin right here. Let me just remove this, and all right. So let's verify it and let's upload it, okay? Let me upload it right here. And it's done compiling, it's uploading, and it's done uploading. All right, so let me remove my Arduino from the 5V and let me move it towards the digital pin, not digital pin, sorry, I said analog pin 4. Let me just do that. All right, there we go. I moved it to analog pin 4 right here, all right? So right now it's lighting up as how a 5V lights it up and a digital pin lights up the LED. So again, you might be confused on why did we use 255 right here? What is the use of it? And not only that too, but it's a very 255, and I'm gonna that we're using, and there's something called the red pin. We said digital right, and we set it to what? What do? We put the red pin right here, and then we set it to high when we were using a digital pin. So right here, it makes sense to write what? Analog pin. There's something called analog right, okay? We do that, and we see a red pin, okay? The pin that we're gonna be using, and then we're gonna put a value. So right here, I'm just gonna put 255, and I'm gonna come back to this and actually explain why did we put 255. So let me just remove this right here, because obviously we're not using a digital pin right here. Let me just remove this, and all right. So let's verify it and let's upload it, okay? Let me upload it right here. And it's done compiling, it's uploading, and it's done uploading. All right, so let me remove my Arduino from the 5V and let me move it towards the digital pin, not digital pin, sorry, I said analog pin 4. Let me just do that. All right, there we go. I moved it to analog pin 4 right here, all right? So right now it's lighting up as how a 5-volt lights it up and a digital pin lights up the LED. So again, you might be confused on why did we use 255 right here? What is the use of it? And not only that too, but it's a very odd number, you know? Why not 300? Why not 200? Why 255 specifically? Okay, so let's see the science behind it to understand why it is 255. And so the question still remains, why are we using integers? So right here, let me start from something that we're familiar with. We use digital write, and then we set our pin, what pin we're going to be using, and then we set it to either high or either low. Obviously, high means 5 volt, which basically is on. Low means 0 volt, which basically is off. It seems to be working perfectly fine, so why do we need integers to represent this? To represent high. High is represented by what? High is represented by 255. Low is represented by 0. Why do we need integers to represent that? Because this gets the job done perfectly, right? So the problem here is when we're using high and low, the problem that arises is we only have two options. We cannot choose anything more than high or low. Let's say I want to set it to medium. Let's say I want to set it to, well, I want it to output 2.5 volts, literally the medium, the half. What happens? I basically cannot output medium because either I can set it to high or either I can set it to what? To low. So this is where integers come in. They come really, really handy, and they allow us to have intermediate values. So if I wanted to set it to medium, what do I need to do? All I need to do is divide 255 by what? By 2, basically giving me half. So let me just bring a paper right here. Okay, there we go. So let's say I want to do 255. I want the half of it. 255 is what? If you remember, 5 volt. All right. I want to output half of 5 volt. It's going to be 2.5 volt right here. All I need to do is what? I need to try to find X right here, how much I should be writing down, and then do the math. And once I do it, X is going to come approximately to 127.5, which you can round up or round down, which I'm going to round up to almost 128. So what does integer allow us to do? Integers allow us to have intermediate values. What else? Let's say I want to do is what? You know what? I don't want it to be half. I want it to what? I want to do 20% of what? The original high that we had. I want 20% of it. I want 20% of 5 volt. I want to output 20% of 5 volt. So let's do the math right here. What's 5 volt? 5 volt is currently 100%.
They cannot even speak when they are hungry. They cannot even speak when they are suffering. They cannot even speak when they are in pain.
What is 20%? All I need to do is find the voltage. Do the math right here. Keep on doing the math right here. 20, okay, it's going to be 0. When you do the math, 0.2 times 5 is going to equal to X. When you do the math right here, 0.2 times 5. All right, so basically what is this? 5 times 2 over 10. When you do the math right here, this is going to be 2 over 2. So we're going to have 1. There we go. 1 is equals to what? X. Basically, we're going to output 1 volt. There we go. So basically what integers allow us to do is what? We can find any value. So we can have any intermediate value between what? Between high and low. So we can have any intermediate value between high and low. Because obviously if I had, let's say, high right here and low, let's say I write down medium for 2.5 volt, and then I write down another name for it. Obviously, you cannot name every instance. You cannot name every, obviously, value of voltage. So we're going to be using integers, doing the math, and after doing the math, we can do what? We can find our desired value and then output the voltage. So basically, we can what? We can control the amount of voltage that's coming in to our Arduino, coming out of our Arduino. So basically, what happens? Basically, we can create dimmer and what? Brighter light. So we can